All right, so we're all up to date. Well, that's too bad. Proving square root of 2 is irrational. Who wants to go over this? It might be like a 10-minute detour, so. Only 2? The rest of you know you don't want to see it? Okay, so you'll just take my word for it.
Is it geometric proof?
No, I would just do simple intuitive proof. Just explain the thinking. I wouldn't have done a full-fledged one. I would have sufficient for the same way I proved the Pythagorean theorem. There was a lot I just said, and you know, type stuff.
I think you showed me before.
Yeah, we do it. We've done it.
Yeah, a lot of you have already seen it, but all right, if you don't want to see it, that's fine. But suffice it to say, since this length cannot be expressed as a rational number, there's a consequence to this that is crucial. The consequence is that there is no unit of measure I can find to measure this side that's small enough that I could also measure this length with that same unit of measure. Does that make sense?
Yeah.
Let's think. So let's say I'm trying to measure this marker and this whiteboard. All right? So I try measuring this whiteboard with markers. And I keep measuring, I keep measuring, I keep measuring, and I find out, oh, there's a little bit of marker left over when I try to just measure it with markers. Maybe I'll just measure them both with lids. And I measure this, and this is exactly 5 lids, and I measure the whiteboard, and it's exactly 256 lids. Okay, I found some unit small enough that I can measure both of these in terms of that unit.
Right.
That's what we're saying. So no matter how teeny tiny small of unit you use, you want to count atoms. You can't do it. There's no small enough unit you could use where you can measure this side in terms of that unit and this length in terms of that unit. That's a consequence of the square root of 2 being irrational.
That's cool.
You can't express it as a ratio. And so that's why it fundamentally breaks down.
So why does this concept in Pythagoreanism continue on when they figure this out? Because doesn't it break down their whole system?
It completely breaks down the system that everything can be expressed in terms of numbers if they don't allow the square root of 2 to be a number, which they don't. Why do they continue when there's an obvious inconsistency? You're just going to abandon everything you know because you find one inconsistency? Because they're people. Same reason that no matter how much evidence you give a flat earther, they still think the earth's flat. And they'll come up with some way to rationalize. Who knows?
When you're pot committed, you just keep going.
Yep.
There's no other choice.
So, who knows? That's just human psychology. All right. Oh, go ahead.
You want to go to the back slide? What does...
Did I skip a slide?
No. What does
Oh.
incommensurable mean?
That's what it means. It means that you cannot find a unit of measure that measures both this and this. They're incommensurable. There isn't some unit of measure that can measure them both.
Okay.
Or there's no ratio that can capture their relationship. Anything else? Okay, so let's get into their cosmology. In particularly, we'll start with their cosmology. Well, that'll probably explain everything. So here's the way that they see the universe in the beginning. In the beginning, there's just the one, the unit. There it is, in space. And they have a little bit of an Anaximenes view of the universe. So it's kind of like there's air out there, but they also say void. So you have unity, and then the void outside of unity. And what happens is, now unity is some limited thing. It's limited in size, it's just unity, it's just one. The void is limitless. And what happens is unity apparently started breathing in the void or the air out there, some of that infinite air, since there's infinite of it. Then unity, one, can sit there and breathe it in, breathe it in, breathe it in, breathe it in, expanding, expanding. And I'm not sure how exactly that leads to other numbers coming into being, but apparently it does. I don't know if they have a notion of like, it goes from the unity that we call 1 to one higher order unity of 10 to one higher order unity of 100. Or if they thought about kind of like how we think about cells now, when cells split, like a cell grows big enough and it splits in two, and those grow and split, grow, split. I'm not sure exactly how they viewed it, but it's definitely the one breathes in the void and thereby creating plurality. So they say that the universe begins, one of the ways it's often summed up, is when the limited breathes in the limitless. Or when the one breathes in the void. I probably wrote one of those. Universe originated when the unit breathed in the void, or when the limitless became bounded by the limited. Similar thing. That's the verbiage. And then the unit breathing in enough void produces more unit somehow. Not sure. And then they went crazy with the 10. So they guessed that there had to be another object out there called the counter-Earth. They also thought that the sun was at the center of the solar system. But the Earth goes around the sun in one day. So it's not nearly the model that Copernicus came up with. It's a very naive version where the Earth goes around the sun once every day, not once every year. And that's what's producing night and day. But anyways, so they thought that there had to be a counter-Earth, which is always on the opposite side of the sun as us. And we never see it. Now, why does there have to be a counter-Earth? Well, let's count all the heavenly objects. You have the stars, you have the sun, you have the new Mercury, Venus, Earth, Mars, Jupiter, Saturn, the moon. That's only 9. There has to be 10. Counter-Earth. And that's where the counter-Earth comes from. And Aristotle belittles them a little bit in his metaphysics over that. So 10 celestial objects. Has to be 10. Always and forever. Now, harmony. Harmony, well, you saw how it pops up a lot of the places. One of the places that they thought harmony had to show up was, well, I'll just read it. They thought disease was due to a lack of harmony in the body. So later Pythagoreans are going to say a fever is because you have disharmony between hot and cold. And so since your body has too much hot, you need more cold. And that's what's going to bring your body back into harmony and restore health. Or some of the other common properties that they talk about hot and cold and wet and dry. So somehow if you're too dry, then that's because you're dehydrated and you need the water to bring the health back. Stuff like that. So describing a lot of things in terms of harmony, not just music. So your body, that's due to harmony. One that's not going to come up here, I don't think I listed it. Well, I'll keep going with these and say it last in case I don't. Held that as medicine brings harmony to the body, so does music bring harmony to the soul. Now, this isn't necessarily just music in the sense that we think about notes playing. This is music as in coming from the muses. So this is more of like your arts education as well. So poetry could also fall in your music, bringing harmony to the soul. But it does include actual music. And this is a notion that we'll see come up again with Plato. He'll say, when you're educating your men, you need to make sure they get a good physical education so that they don't become too effeminate. And you also need to make sure that they get a musical education so that they don't become too brutal. And so there's this notion of bringing harmony to them through that kind of education. And then here he means music in the sense that we mean music. Believed in the music of the spheres. So remember, this is crazy to him, that you take this string and you just pluck it and it produces music. Somehow motion at a set distance produces a note. So they believed in the harmony or the music of the spheres. They believed that as things move in the heavens, they actually are giving off music. So Jupiter is giving off music. Earth is giving off music as it moves. Now you might say, are these guys deaf? Can they not hear? I don't hear any music. Why don't I hear the music of the spheres? They say the reason that you can't hear the music of the spheres is because you've always heard the music of the spheres. You have nothing to contrast it with. You think that what you call no sound is the music of the spheres. So, thought that the spheres were very much giving off music. And then one philosopher sums up the Pythagorean contributions. It is not too much to say that Greek philosophy was henceforward to be dominated by the notion of the perfectly tuned string. We're going to see harmony come up over and over again. Harmony in the soul, harmony in your laws, harmony in your medicine. And we've already seen harmony coming up with the 4 elements competing with each other. So it's a notion that the Pythagoreans, once they realized that there's this harmony in music, how it can be expressed mathematically, it is used a lot in other fields is one way to say it. Anyways, so I think that pretty much finishes off Pythagoras. Got one little nice picture there that I thought summed him up pretty good. got them there with the Pythagorean theorem and holding that, but you got the tetractys right above them. Some weird symbols over here. You got the lyre back there with the strings. So, mystic mathematician, kind of a cult leader. So, that's Pythagoras. Any questions on Pythagoras?
I'm sure the video does.
Yeah. Well,
It's too bad we don't know more about him.
yep. One of those people that we could know a ton about him, or we could know hardly anything about him. Hard to know. Because a lot comes out of school.
Donnie, who came up with phi?
Phi, the golden ratio, that is, no, that can't be Euler. It's much later though. Yeah, the golden ratio, that's going to be, is it Euler? Might be Euler.
What's the mill ratio like? The actual ratio.
The numbers, I don't know, 1 point, I think it starts with 6. But it's just a ratio, kind of like pi's ratio. So, but that is much later. Let's think. Oh, maybe it's Fibonacci. Yeah, because one of the ways that you can get it is from the Fibonacci sequence. The ratio of each number in the Fibonacci sequence gets closer and closer to approximating it.
Oh yeah, I remember you teaching this.
1, 1, 1, 2, 3, 5, 8. If you keep adding up the numbers, 5 plus 8 is 12. 8 plus 12 is 20. Oh, thank you. I was going to say, that is not right. Don't recognize it. 8 plus 13 is 21, 34. Keep going like this. The phi, that ratio, becomes, you slowly approximate if you look at the ratio of two consecutive numbers. So 3/5 is close, but 5/8 is closer. 8/13 is even closer. 13/21, etc. This gets closer and closer to it.
What's its exact definition?
It can be expressed as an infinite. Let me think. The way that it first came to be is if I have a rectangle. Imagine I have some rectangle so that this is 1 and this is then going to be my phi. And it is the length that makes so that when I cut a square off of this rectangle, then this resulting rectangle has the same ratio. So that's where it initially comes into play. I think that is one place, but I think that's how it initially came.
Oh, I see.
Yeah. So,
That's weird. Yeah.
but much later in history, we're talking about thousands of years after Pythagoras. Anything else?
It was
Fibonacci? Okay. That's it? Okay. I don't know, we need to do a recap at the end of the class since it was just Pythagoras. You good?
I'm good.
Okay. Before we end, any feedback, anything you guys like, didn't like, want change for next time, other than actually recording the lecture? It's a bit much to ask, but I think I can do that one. Can't believe that.
That's so sad. This is really good one.
Yeah, Pythagoras is really fun.
This was a good
Yeah.
This was, he's cool.
That's nice.
Well, he monument, great.
Yep, and we missed the Pythagorean theorem.
Everything.
Okay, so if you have no feedback, no notes, then we're good. Those of you trying to get credit for the class, stay for a sec.
Yeah.
Make sure I get your stuff. And see you guys next week.
Yep.
How disappointing.